So this is actually a very good question, and one that to answer in full detail would require a lot more background, but I'm gonna give it my best shot based on what we know so far. So these crystals will be used to make a bunch of particle detectors, and I mentioned in my last video sort of how those detectors work a little bit. I'll have to get into more detail later, but essentially we're gonna make a lot of these particle detectors and put them in an array. And then this array will be used in an experiment in which we will shoot neutrons at something, a target, as we call it. And then when the neutrons hit that target, it'll become radioactive, it'll emit gammas, and then our detectors that we are building with these crystals will measure those gammas. But to understand why we're using these crystals specifically, the barium fluoride, we need to go into a little bit more depth. So let's consult the whiteboard. So in my previous video, I went over what a scintillator is and how it works. And these scintillators, when you use them in a detector, lead to a signal. And this is what the signal looks like when we actually measure a particle hitting the scintillator. So we have baseline, no signal, boom, a big spike, and then the spike dies off. And based on what kind of crystal we use, what kind of scintillator material, and also the electronics we use, this peak will be a certain width in time. So it'll take a certain amount of time for this peak to appear and then to go away. And that time is what tells us how carefully and how precisely we can measure when these events occurred. So if our time resolution is very low or is very bad, then we don't really know when these things occurred. But if we have good time resolution, then we can know exactly when the gamma hit the crystal. So what we want in this experiment is we want to know exactly when the neutrons came and hit the target. And when the neutrons hit the target, they emit these gammas. And then this is our array of detectors all around the target. So this will be completely surrounding the target if I could go in 3D. And by using these barium fluoride crystals, which are very good at telling time, so all this process that goes on in the crystal of emitting these photons, that happens very quickly, which means that this time is very short. So we have great time resolution. And then that means we can tell how this process occurred and when it occurred very precisely. And this very high timing resolution is what makes barium fluoride very rare, very valuable, and also extremely expensive. So if you saw my previous video of cleaning all 300 crystals, thankfully I did not drop one. Knock on wood that I don't the next time.